Welcome to JD's Prep. So we have a lab exercise here that is comparing the effects of particle diameter on permeability and porosity, which is the percentage of pore space. So we have 4 separate plastic tubes, sand, clay, a mixture, and plastic beads, and we have the data here below. So our first question is asking us why the particle sizes fit together more closely in the mixture, resulting in the lowest porosity of all these particle types. So the porosity here of the mixture is, you can see, is the lowest. And right here, this is the mixture. It has pebbles, sand, silt, and clay. So ultimately, the smaller particles there are just going to fill the pore spaces between the larger particles. It just means there's going to be less open pore space overall. And that's why that has the lowest porosity. Next, we're told that the height of the column of sand is 28 centimeters, and we're asked to calculate the rate of infiltration in centimeters per second for the water that flowed through the column of sand. I've pulled this out from your reference tables, which is just our simple calculation to find a rate of change. Change in value, so the water flowed through 28 centimeters, and the time, sand, was in 7 seconds. That's going to give us 4 centimeters per second. And lastly, based on the particle diameter of the plastic beads, identify the type of sediment represented by these beads. So the particle diameter is 0.4. I'm heading to the reference tables to find this. So 0.4 would land the particle diameter somewhere in between here. So we would say that it's representing pebbles. All right, thank you for using JD's Prep.